Okie dokie. Functions and graphs. There's some things on here that we don't really care about, but I want to show you because we start getting into this idea of what I call calculus speak versus what normal people use when they talk about math. We'll get to that in a minute, but we're going to talk about functions and graphs. A lot of times I'll start with a simple slide that asks you a series of questions, which is basically a preemptive strike on what we're going to be talking about today, and ask you a series of questions like, can you use function notation to represent an evaluated function? Do you know what function notation is? You better. F of x, that kind of stuff. Getting away from the y equals stuff and moving into the f of x. Domain and range. Okay, easy. Domain is x, range is y. No problem. Sketch a graph we talked a little bit about. We'll get some repetition here too. We talked about the mother functions, but we'll use the mother functions to graph. Composite functions. People are always weak on composite functions, so we'll review those. Do you know what I mean by composite functions? What's a composite function? Okay. Tell me your name. I'm still learning names.
Sarah.
Sarah, what's a composite function?
Sure.
Anybody? Casey?
This is like two functions put together into one.
How put together? Yes, kind of, maybe.
Yeah.
Depends on how you answer that follow-up question.
I don't really know how you put them together.
Because you could add them, subtract them, multiply, divide them. You could.
Yeah,
So if you just stick them together, you got a composite function?
I guess so.
Not quite, but close. Okay.
Is it like f of b of x? So it's like the answer to b of x is you put that into x for f of x?
Good. Yeah, you put one function in the other.
Oh.
Okay. You knew that, right? You just said another f of g, g of f. Remember those? Yeah, a little circly thing. Yeah, we'll get to those. That's not today, though. Everybody's favorite polynomial inequalities. Piecewise functions. Yeah. And then your friend and mine, step function, also known as the greatest integer function. One possible example of a step function. Okay, so this first slide you know already, but I want to show you the difference between what we're going to use in our conversations versus what calculus speak uses. So that top paragraph there, let x and y be the set of real numbers, a real valued function alpha for the real variable x from capital X to y is a correspondence that assigns each number in x, each number x in x exactly one number y in y. The domain of f is, okay, got that? What is that saying in English? All the x's are the domains, all the y's are the ranges. That's it. Okay. Why can't they just say that? Because there's a lot of other things going on in the background that that they care about more so than we care about. So that'll happen a lot. And you'll see a lot of times I'll throw the calculus speak up there because you should be exposed to it, but we'll also talk about the English version of exactly what we're trying to say here. The other thing is that I assume you're good with independent and dependent variables. Is that a safe assumption? X is the independent variable because you can choose X to be whatever you want. Y is the, sound like Porky Pig there, is the dependent variable. Do you guys even know who Porky Pig is?
Yeah.
All right, just checking. Where was I?
Porky Pig.
No, before Porky Pig. Y is a dependent variable because Y is dependent on what values you choose for X. Okay, so a little dabbling here in composite functions. Let's start with the easy one of A. What does f of 3a mean? Not what's the answer, but what is it asking you to do? Paul.
Plug 3a for x.
Perfect. And then simplify.
Yeah.
Right? Okay, do that, please. And then simplify it. Easy peasy lemon squeezy? Any problems? Yes or no? No, good. Okay, remember it's 3a quantity squared plus 7, which gives us 9a squared plus 7. We good? Thumbs up? Yep. Excellent. Okay, let's move on to the second one. Parts Bay. Paul, back to you. What does part B say? What does that mean?
Plug in b minus 1 to x.
Good. Okay, so before we move forward, as we progress through this, it becomes more and more challenging. What would f of smiley face be? What does that mean? Smiley face squared plus 7. It doesn't matter what's in parentheses. You go to the original function, wherever there's an x, put in that thing, whether that thing is a smiley face of 3a, a b minus 1, or this mess over here, which we'll get to in a second. Okay, so this would be equal to b minus 1 quant. Ooh, my parentheses are a little out of control. B minus 1. How are you going to deal with the b minus 1 quantity squared? Are you one of those people that writes b minus 1 times b minus 1 and then FOILs? Whatever works for you. If that works, great. Does anybody know the shortcut? Josh?
It's like, no, but it's like the coefficient is like 1, 2, 1.
Ooh. Pascal's triangle.
Yeah.
You getting all fancies in your fancies. Nice. How does that apply here?
There's only 1b squared, and then there's 2 negative b's, and then there's 1 positive 1.
Good. Okay. Which is great, except when they get more complicated, it gets a little nastier, and Pascal doesn't really help that much. In a practical sense, there's nothing wrong with writing b minus 1 times b minus 1. It just takes a lot of time, and time does become an issue in a lot of the stuff we do. So the rule that I use is take the first term and square it, multiply the two terms together. B times negative 1 is negative b. Double it, negative 2b, or not 2b, that is the question. Thank you. Square the last term. Done. Okay, so again, square the first term, multiply the two terms together, double it, square the last term. And then, of course, negative b squared, or sorry, b squared minus 2b plus the 8. Easy peasy? Beautiful. This last one, have you seen it before? This f of x plus delta x minus f of x all over delta x. Did you do that at all last year?
I think we used
You used h.
Yeah.
X plus h minus f of x all over h.
Yeah.
Same thing, different form. Okay. We're going to do this ad nauseum because it's a crucial concept. You know the term ad nauseum? It's Latin that means until you puke. Literally translates it until you puke. Right. So we're going to do this a lot because it's a basic foundation for derivatives in calculus. But again, just take it in the parts. We've done b minus 1, so we should be able to do x plus delta x. We don't have to do anything with f of x, and then you don't have to do anything with delta x. So we get x plus delta x, quantity squared, plus 7. That takes care of that guy. We use Christmas colors. Minus f of x, which is just the function, all over delta x. The biggest mistake that people make, if they understand the concept of putting functions into other functions, is those parentheses in green. Those are crucial. Because without those parentheses, it doesn't turn the 7 into a negative value. It stays a positive 7, which is bad. Okay, let's keep things clean here. We'll put an equal sign there. Using what we just talked about, Amanda, what is x plus delta x quantity squared?
X squared plus 2 delta x plus delta x squared.
Well done. Okay, so far, 7's canceled. X squared's canceled. And we're left with 2 delta x minus delta x squared all over delta x.
Yeah, why is there no x in the
Yeah.
2 delta x?
I suppose anyway?
So,
This should be plus.
yeah, but also isn't it like 2 delta x, shouldn't it be like 2 delta xx?
It should be. I think you said that, Amanda, and I just didn't write it down correctly. Right?
Yes.
Admiral. Even if it wasn't, just say it right. Okay, so I screwed up. I should have an X in there. I'm going to put it up here to keep things cleaner. Good job. You could cancel the delta X's. However, when things get more complicated, that could lead you to some sloppy math. So what I would prefer is to factor out the delta X. Then cancel, and we're done. 2x plus delta x. That's not quite a derivative, but it's pretty close to a derivative, and we'll talk about what a derivative is later. But that whole process we're going to do quite a bit. And what do we care about out of it? What are we trying to get out of it? It's just this idea of taking this expression and putting it into another function and simplifying it. Okay, problems? Awesome. Get rid of this. What are the two things we care about when we're dealing with a real, when we're dealing with the real number system? What's bad?
Dividing by
Sorry,
0.
Josh.
Dividing by 0.
Good. And I don't know what order I have them in, so I'm not going to move forward because I would give you the other one, Tim.
Square root by negative.
Yep. That's it. Everything else is good to go. Okay. And later on, we'll actually contradict it a little bit with zero denominators, but I talked about that a long time ago, and we won't get into it till like March. So for now. Okay. So that function, first of all, what's the mother function here? What is that function based off of?
Realvalued.
No. Actually, that's a difficult question. We'll skip that. What's the domain restrictions here? In other words, what can't, well, we can ask the question two ways. We can either ask what can x be, or we can ask what can't x be. This case, it's a little bit easier. Well, it's about the same. Tim,
X can't be plus or minus 2.
anything else? You want to stay with just those two?
Yeah.
So negative 2 and positive 2 are bad.
Right.
Everything else is good.
Yes.
Okay? Now, it would be nice if they just asked you which ones don't work, because then you could just say x is not equal to 2 or plus or minus 2.
Oh, so do you want me to do like negative infinity to 2 like that?
Little interval notation review?
Yeah.
Sure, go ahead.
Um,
If you want to get up and stretch your legs, yeah. Or you could sit there and just tell me.
It's open parenthesis, negative infinity, comma, negative 2 with the close. No, open, like not the bracket, the parenthesis. And then it's negative 2 to
Excuse me. Sorry.
positive 2, both with just normal parentheses. And then it's positive 2 to positive infinity.
Everybody get that? So they're all parentheses. No brackets.
Yes.
Does everybody agree? Yeah. Okay. Hi, Mr. Bob. Whoops, wrong way. Oh, good, well done. Okay. No brackets on infinity ever, because you can never get to infinity. No brackets on the negative 2 and 2, because we're excluding those. If you're feeling all fancies in your pantsies too, you want to be sure to include that union symbol there. That means you're putting all those together. That's a pain in the butt. Again, it would be a lot easier if we could just say x is not 2 nor negative 2, but it doesn't always work out that way. And again, this is review, right? Good. Okay, a couple things in this slide. The first thing is if you're given the picture of a function, 99% of the general populace can tell me what the domain and range restrictions are. Looking at the picture, we know where the x starts and where it ends. We know where the y starts and where it ends. It gets a little bit more difficult when you just have a function to operate with. So you can do that a couple different ways. You could graph it and then answer it based on the graph, or you can do the math. Sometimes the math gets a little bit nastier. But for instance, a square root, we figure out what x can be. Remember, a common mistake here is you can have the square root of 0. What's the square root of 0? 0, right. That's okay, it just can't be negative, which is illustrated in the picture there. So we got that mother function of the square root of x that's being shifted 1 unit to the right. And then the last thing is, I think this is the last thing, 1 to 1. 1 to 1 means that for every x there's exactly 1 y, and for every y there's exactly 1 x. So if we take a common function like a parabola, x squared, that is not a 1 to 1 function. Because for y values there, we get 2 different x values, plus or minus 2. That gives us 4. And we'll be talking a little bit more in the future about why we care about 1 to 1, but it's a little ways away. Okay, we're done already. But now we're going to talk about thank you cards. So let me stop the recording for a second. Recording. Where are you?